Now let's try to understand symmetric signal and antisymmetric signal. So symmetric signals are also called as even signal. Antisymmetric signals are also called as odd signal. So let's start with symmetric signal. So a continuous time signal is said to be symmetric if it satisfies the condition. Which condition? So see this condition, x of minus t is equal to x of t for all t. Okay, so if we have some continuous time signal and if that continuous time signal is satisfying this particular condition, then that continuous time signal is said to be symmetric signal. So let's try to understand it with the help of one example. Suppose here we have one signal. On x-axis I have shown one variable t. On y-axis I have shown x of t. So x of t means value of function x of t. Now consider this particular point. Okay, so at this point let's assume that t is 5 and here t is minus 5. So here if we compare these two values, which two values? Suppose x of 5, if I compare this value with x of minus 5, so whether these two values are same? Yes. So x of 5, okay, so here we have some value, and if we compare this particular value with x of minus 5, so can I say that these two values are same? Yes. That is whether this condition is satisfied for t equal to minus 5. Yes. So x of minus t is equal to x of t. Now consider one more value of t. Suppose somewhere here value of t is 1 and suppose here value of t is minus 1. So again if we compare x of 1 and x of minus 1 for this particular signal, we will come to know that x of 1 and x of minus 1, they are also same. So if this particular condition is getting satisfied for all values of t, then that particular signal is said to be a symmetric signal. Now let's discuss what is meant by antisymmetric signal. So a continuous signal is said to be antisymmetric if it satisfies following condition. So which is condition? X of minus t is equal to minus x of t for all values of t. So please try to understand difference between the condition for symmetric signal and the condition for antisymmetric signal. So condition for antisymmetric signal is x of minus t, it should be equal to minus of x of t. Now let's try to understand it with the help of one example. So consider this signal. So here if we consider value of x of 5 and x of minus 5, so whether this particular condition will get satisfied? Yes. So x of 5 is some positive value here, okay, and x of minus 5 is some negative value, and again magnitude of x of t at t equal to 5 and t equal to minus 5 will be same. Okay, so this particular condition will get satisfied for all values of t. So that's why this particular continuous signal, continuous time signal, can be considered as antisymmetric. Now let's see what is meant by periodic and non-periodic signal. Non-periodic signals are also called as aperiodic signal. So let's start with periodic signal. A signal is said to be a periodic if it repeats itself after regular interval of time. Very simple. So let's assume that we have some signal like this, okay, and let us assume that this signal is repeating itself. Okay, so see this signal is repeating itself after regular interval of time. So see this particular portion of this signal is getting repeated, and if this repetition is after regular interval of time, then that signal will become periodic. Now in signal we have seen that signal may be a continuous time signal or it may be a discrete time signal. So if we have continuous time signal, so a continuous time signal is said to be a periodic if it satisfies the condition. Which condition? The condition which is given here. So x of small t plus capital T is equal to x of small t for all small t. So here what is small t? So let's assume that it is independent variable, okay, on which this signal x depends. And what is this t? So t is time interval. So let's assume that t is time interval after which this particular signal is getting repeated. So if this condition is satisfied, x of t plus capital T. So what is capital T? It is time interval after which it is expected that this particular signal should repeat itself. So x of t plus capital T, it should be equal to x of t. Okay, and this condition should get satisfied for all values of t. Then that continuous time signal is said to be periodic. Now consider this particular signal. So whether it is periodic, yes. Why? Because this particular portion is getting repeated. So see, here we can see this portion of a signal here, as well as the same portion is observed here also, same portion is observed here also. So this signal is getting repeated. But whether it is repeating after regular interval of time, yes. So see, what is time interval here? Minus t to 0 means it is t. Okay, then what is time interval here? Here again it is 0 to t. Okay, then this is t to 2t, means here also time interval is again t. Okay, so here if I consider this x of 0, so what is x of 0? So from this diagram it is clear that x of 0 will be 0. Okay, now x of 0, what is time interval for this particular signal? I told you that time interval will be t. So x of 0 plus t. So what is the value of x of 0 plus t? So x of 0, so in that 0 add t, we will get here, we will get x of 0 plus t here. So what will be the value of x of 0 plus t? Yes, again it will be 0. So whether this condition is getting satisfied, x of t, small t plus capital T. So here what is small t? 0. So x of 0 plus capital T, whether it is equal to x of small t. Yes, this condition is getting satisfied for t is equal to 0. Similarly, you can verify that this condition, okay, this particular condition will get satisfied for all values of t for this particular signal. So that's why this continuous time signal can be considered as periodic. Now let's see discrete time signal. So a discrete time signal is said to be periodic if it satisfies following condition. So the condition is same: x of n, small n, is equal to x of small n plus capital N for all values of small n. So here what is capital N? Yes, so capital N, again it is a time period after which it is expected that this particular signal, it should get repeated. Okay, so consider this discrete time signal. So whether this discrete time signal is repeating itself, yes, it is repeating itself. So if you observe this diagram, you will come to know that this particular portion of this discrete time signal is getting repeated. So see, same signal is observed here also, same signal is observed here also. So if you observe again carefully values of small n, okay, then you will come to know that this signal is repeating itself after a regular interval of time. So that's why this particular discrete time signal is said to be periodic. Now let's see what is meant by aperiodic signal. So if you understood periodic signal, you can easily understand what is meant by non-periodic signal. So when we can say that some signal is non-periodic, if that signal is not repeating itself after regular interval of time, then it can be considered as non-periodic or aperiodic signal. So consider this particular signal. So whether this signal is repeating itself, no, it is not repeating itself. So that's why it can be considered as aperiodic signal. Now let's try to understand what is meant by causal signal and non-causal signal. So a continuous time signal x of t is said to be causal if x of t is equal to 0 for t less than 0. So if this particular condition, which condition? X of t should be 0. So value of that signal should be 0 for all values of t which are less than 0. So if this condition is satisfied, then that particular continuous time signal can be considered as causal. Otherwise, that continuous time signal, it should be considered as non-causal signal. Let's try to understand it with the help of diagram. So see this signal x of t. So this is signal which depends on variable t. So t is independent variable. So if you observe this signal, you will come to know that value of this signal is 0. Okay, it is 0. So see here, value of this signal is 0 for all values of t which are less than 0. So that's why this signal, it should be considered as causal. And consider this another example of signal. So for this signal, what is the value of x of t? Whether x of t is 0 for t less than 0? No, x of t is not 0. Here x of t has some positive or negative value. X of t has either positive or negative value for all values of t which are less than 0. So that's why this signal, it should be considered as non-causal signal. So similar condition is applicable to discrete time signal also.